Welcome to the topics in computer science session. Last time we completed the relational database part. We discussed starting from database modeling to MySQL. So with that, we finished that discussion on relational databases. So today we are going to briefly looking at software development methods. But before that, we will look at different methodologies that we will use to starting from planning to develop the information systems. So that's the discussion today. So we will discuss four main software development techniques, and then we will conclude our session by discussing various ways that we need to make a decision whether you are going to uh, purchase or the develop the software. So that's the plan for today. So if you look at the software development methodology, that means when you want to develop a piece of software for an organization, you need to look at the requirement for a information system. So let's say your organization needs to build a new software. So then you need some careful planning. So you need to follow different phases. So you need some kind of a framework to do that. So here I listed like four examples that traditionally we have something called system development life cycle or waterfall technique we said. That is traditionally how we develop the software system. Then if you look at more recent one, we will also going to discuss in brief on joint application development, rapid application development, and the latest that is agile software development. Let's start. So when we look at software development life cycle, I told you this is very traditional structured way of developing or implementing software systems. Usually you can find 5 stages in system development life cycle. The initial stage, we start with system planning. Then we have system analysis, system design, system implementation, and system support and security. So these are the crucial or 5 stages we need to follow. So this graphic will show you each of these steps and its outcome. So the initial stage, we said system planning, where we need to consider why we need it. So we need careful planning for system development. So once we do that, you have to prepare a report which you are going to present into your higher level, which they are going to decide whether they are going to develop the system. Now, for example, things like the cost is take to develop a software system, and whether they have enough staff strength to use the system when they implement. So these things that you need to develop in the early stages. So we call system planning stage. Right. Once you get a green light from system planning, then you are going to work on gathering all the requirements. This happens in the system analysis phase. So during this phase, what happens, you look at all the information that you need to develop this, right? So the idea is you are going to build the model. You find the facts. So you can, for example, use different fact-finding techniques to gather information. For example, you can use interviews. For example, let's say you are going to build a system for your organization. Then the higher level management people, you can meet and discuss their requirement in detail. You can perform questionnaires, or you can use surveys to gather information from general users, because there could be many users who intended to use your system. So individually contacting them may not be practical. Then you can also look at various different types of documents available in your organization to understand the reporting requirements. Then you can actually, for example, in case if you're not familiar with the domain, then you can simply observe what is happening in a particular organization. And that could be one of the early, fact-finding technique. And also you can look at for sampling. So during this period, what happens, you create various different models. We call it business models, data and process models, for example. How the users are interact with the system, what data is actually transferred from one place to other place. So this is happening in the system analysis stage. And if you're using object oriented modeling, which you are going to think each and everyone has different models, then you can build models on objects. So at the end of this session, what we are going to have is what we call system requirements document. So now, by the first two phases, now everything is ready. Then you have to have a system design specification. When we say system design specification, so during this phase, you have to create the physical model, like what we did. So this stage, you can design things like user interfaces. You can decide on what inputs and outputs and processes are needed. And then you can determine the architecture. When I say architecture, for example, whether you want to build a web-based system or mobile or a desktop. And then depending on the choice, you have to make the architecture. So once you make that decision in this stage, then programmers can take into consideration, and then they can create the code to implement this. So at the end of this phase, you will get what we call system design specification. So that is our third one. Next one is system implementation, which is again very important. Once you have everything, now you have to create this. So you first of all, for example, you have to decide on what programming languages you are using, what frameworks you are using. So at this stage, you will develop the programs. You write, you test, you document, right? And then you can actually, install the system if it's a success. But at the same time, I told you, like, you don't have to build the system or develop the system. Sometimes you can, get, or you can purchase the system. But even if you purchase a system, then you have to make some modifications, and then you have to configure the software. So again, you need to spend some time on this. So what happens at the end of this phase is, we can assume that you will get a completely functioning information system, right? So the system is ready by this stage. Right. The next part would be the last part, that is system security and support. That means, once you get to this point, you can keep on looking at whether whether there are any errors we made while working in the previous stages. Right. So usually different set of staff members are involved in this. There are some, IT staff maintainers, and they are the ones who actually enhance or protect the system. So during this stage, we can make or we can correct some errors, and then we can make the changes to the environment. And you can provide new features and benefits. Sometimes there could be feature requests once you actually deploy the system. And the idea is we want to maximize the return during this period. Another point is, once you have a well-designed system, so it should be secure, reliable, and scalable. So at the end of this phase, we can assume that the system is ready, which means it's a fully operational system. Right. So now that we have got a good understanding about the structured development, the next thing is we need to look at more recent one. Another way of developing application is use of JET, joint application development. This is we call a team-based approach. And then this is the first place you will notice that users are involved in the development stage. So how it happens, usually they meet over a period of days or weeks, and then they analyze what is in the existing system, and then you will get the user expectations, and then also the document the new user requirements. Now, once you do that, yes, that is what we can use. The advantages you will get is mainly users can participate in the requirement modeling process. So assuming that happen, we can assume that this will result more accurate system. Okay, there are some disadvantages as well, because this is more expensive, and sometimes when the group is too large to relative the size, it will cause a lot of issues. Okay, third one we call rapid application development, or RAD. Again, it's also a team-based technique, and the input will be the information system, and then you will get what you get, the functioning information system. So the end product is the new information system. It's a complete methodology, the 4 phases of life cycle. Parallelly, you can work in the rapid application development also. Right. If you ask me like why people want to use rapid application development, because you want to reduce the cost. In rapid application development, the idea is, usually traditional one takes quite a lot of time. You are going to complete everything to go to the next one. Similar to JAD, RAD is also heavily relies on prototyping as well as users involvement. But on the other hand, the advantage the users get here, that they'll get a working model and very early stage. So in this way, they will have a better understanding of the system that is being developed, which they can decide whether the software meets their needs, and also they can also request any changes to be made. So what happens based on the user input, the prototype is modified, and then this will be repeated for some iteration until the system is completely developed and the users are satisfied. Right, these are the 4 stages that we discussed earlier. Rapid application development. What you notice is the first stage will be the requirements planning task. Usually, the users, managers, IT staff in uh, have a discussion on business need, project scope, and system requirements. And then they have to get the approval from the higher authority. Once you do that, you can go to user design task. So from here onwards, you have to get the users on board, and you need to create build and the prototypes, and then intensive chat type session. Now, once you finish that, then we'll move to the third one, construction task. You can develop the program and application development, coding, and then also the testing happens here. Finally, we call cutover. And what happens once you fully implemented, if you already have some data in some legacy system, you have to convert the data. Then full case testing, system changeover, user training, all these we have to satisfy in the fourth stage. Right. If you go back to why rapid application developments is important or the advantages, it will be more quicker compared to our previous traditional life cycle development, and it will significantly reduce the cost as well. Right. But the problem with the RAD is it will not emphasize the company strategy. So it might work well for a short term, but when you want to make it a long term, that might be an issue. Right. Let's move to the last one, agile methods. So agile methods attempt to deliver system incrementally by building a series of prototypes and constantly adjusting the user requirements. As you can see, that is the most commonly used one. Again, like in previous case, users are involved. And the process continues. Developers revise, extend, and merge their versions in the final product. And it's always emphasized on the continuous feedback from the users. And each incremental step is affected by what was learned in the prior step. Some examples include Scrum. So in brief, this will show you Scrum methodology. And here, all the features, we call it product backlogs. So you can see all the requirements are collected. And then they have a fixed term we call sprint. Usually the time frame is about 2 to 4 weeks time. So you will select one or two features to be implemented from the product backlog, and then you can check that. And then you need to plan that piece, and then you have to implement. So once you are implementing this, remember this the team regularly meets. Usually they will have a daily meetings. Usually they will request information about the blockers. For example, in our case, we want to know whether the in this particular case, let's say we want to develop some feature. So during the morning session, for example, in the meeting, they can check what problems they have in the implementation. So while meeting frequently, we can minimize any communication gaps, as well as we can provide answers for the common problems. Right. So Scrum, again, there are a few ways that it will work. For example, they have particular designators like pigs or the chickens. So pigs is in, for example, they are the who owns the product. We call product owner, and we can also say facilitator. Then development team, and then chickens means we have users and other stakeholders and managers comes under chickens, right? So when we have a specific guideline, we have time blocks, interactions, team-based activities, which will result the deliverable software. So idea in Agile is it uses a series of what we call scrums, and you can record the actions, and then you can make any changes until the next scrum. Okay, let's discuss the advantages and disadvantages. So the idea in Agile is it's flexible and efficient in dealing with the change. So we stress on team interactions, and we have frequent deliverables compared to the other models. But then there are some disadvantages as well. So you have to have high level technical skills, and also these models will not focus on documentation. But this lack of documentation might introduce various risk factors. So the overall project, it can be subject to significant change in the scope as user requirements continue to evolve during the project. So that's another thing that we need to remember. Right. Now, having said that, let's have a small group work. What I want you to do is, let me. So in this part, we are going to look at the software development strategies, looking at what is happening right now in the software industry. So if you look back in the early days, usually people develop the software themselves, or you purchase software package, or maybe you can even hire a person as a consultant, or you can hire outside resources to perform the development. Now, with the recent development in information technology or as computing, so things have changed. Now we have a lot of options. For example, there are application service providers. That means there are companies who serves the commonly used packages. There are web hosted software options, and then again there are firms who offer the enterprise-wide software solution. When we say enterprise-wide, meaning for the whole organization, we can use one single software, which goes from HR to the technical department and covering everyone, right? But which one is the best one is crucial and very important decision. So in this part, we are going to look at how you may make that selection. Right now, so with the internet, although the software development also has changed, and then moved to the model called software as a service. In traditionally, we used to develop and sell application packages, and that means you have to purchase something called licenses. That means like you purchase or you pay for what you use, like for example yearly you can make the payment and so on. So by doing so, what happens, the users get the chance to make use of their software. Now the SaaS model, on the other hand, what has happened, it is hosted in the cloud. These are like cloud-based services, and then putting everything in the cloud will reduce a lot of manual labor, especially for maintenance, operations, and the support. Even things like changing your operating system, or the improving your operating system will not affect your software. Right now, if you look back, particularly the software as a solution, for example, early days, what we had everything on premise, which means all the hardware. That means all the hardware component that you want to host your web application or application is in the place. Operating system and other middleware, your data application, everything you manage by you. But now with the cloud, what has happened, things, there's no point of sometimes buying this physical hardware because things may be replaced within 2-3 years time. So it's best that you are not going to purchase, but you actually get it as a what we call infrastructure as a service. So there are websites that we can actually use, in this particular case, purchasing, whatever the hardware stuff you can directly get from them. So that is the idea in the cloud. And then what has happened, even the development part, you don't need to maintain that part as well. That also can put in the cloud. So this is called platform as a service. Usually you will have put everything except your application and data you manage by yourself. But then you have everything. That means you are making use of software provided by the developers, so which we call the software as a service. So just to give you some examples of softwares, this is a bit old, but I think most of the things that we can actually see still. For example, if you look at the productivity side, individual productivity, we can talk about Microsoft Office or Google Workspace. But if you want to talk about working as a team in the cloud, we can use what we call Trello or Jira. You can think about in communication, we can use Slack or a Zoom. Automated workflows can be done as Zapier. So this is coming from productivity, but a specialized one, for example, web development, e-commerce solution, customer relation management, then there are several options are there you to choose. And if you go to enterprise management level in finance, you have SAP and Oracle. And HR, we have Bamboo, for example, procurement, vendor panel, supply chain, stock IQ, and then even administration, DocuSign, especially when you want to sign and send documents. So as you can see, in almost all the sectors now, we can find software suitable on the cloud. Now, the foundational idea in this particular case is your entire business and your employees, they can use their tools online rented products, right? So, but the thing is you have to have an internet, reliable internet connectivity and, use this. But it's easier because you don't have to, maintain your software. But if you look at, two types of developments. In traditional systems, we have various hardware and software environments. And then you can also should be able to compatible with the legacy system, the old systems, and then operate within the constraints of the company networks. Right. In contrast, internet-based systems, we use web as the platform. In many companies, you can see they offer the web-based systems where they will handle enterprise-wide application. So compared to traditional system, web-based systems are more scalable, less dependent on specific hardware and software, and more adaptable to outsourcing the operation and support the software application. So there are always you have a positive side of this as well as a negative side of this. So in traditional system software development, the system design influenced by the compatibility issues because you have already sometimes have legacy system that you want to continue with, and software platforms, and then legacy system requirements. And systems are designed to run on local and wide area company networks, and systems often utilize internet links and resources. Then development typically follows one or three paths. We can talk about in-house development, which means we develop the software ourselves, or you can purchase software package, or you can use some of the consultants. And if you look at the web-based development, there are system developed and delivered in internet-based frameworks. For example, Google App Engine, AWS Lambda could be like some example in this regard. And then what we say about the internet-based development, meaning like you take web as the platform, right? And we know that web-based systems are easily scalable. For example, initially you might have few users who uses your software, but then when it grows, it's easily scalable in the cloud. Then web-based software, on the other hand, compared to desktop computing and resources, are very less dependent, because you have to have a normal computer with internet connectivity, right? So when companies need or use web-based software as a service, then you can limit in-house involvement, which minimize the maintenance. At the same time, the vendor can configure and maintain, and as well as initially, if you request some changes, that can also be done. But remember, web-based software, usually you need additional layers we call middleware, which is to communicate with existing software and legacy systems. Right. So the cloud computing, usually we have seen as a kind of a symbol as a cloud. And then people actually talk a lot about cloud computing, I think, the last couple of years, which will provide you the complete online software and also maintaining data, which uses the supercomputer technology. And then this is what we expect. The minimum requirement of internet connection and browser, you can work with the cloud software. So here is how the web actually changes over the years. We initially had HTML, e-commerce, and so on, but now with Web 2, we have social media, and then global internet access, high-speed communication. But now Web 3 is the future. We have semantic webs, NFTs, use of artificial intelligence, and so on. Right. Now we discuss about how to development strategies, but another option is you can outsource, right? So outsourcing means you transfer the information system development and or maintenance to outside firm, right? Usually you agree for a fee for a year, and then they perform the service. There are two types of service providers: application service providers and internet business services. If you look at the application service providers, it's deliver the software application, or else you can access an application by charging a user subscription fee. So this is the most common one. And provide more than a license to use software. It rents the operational packages to the customer. And then application service provider typically provide commercially available software such as database and accounting packages. So if a company uses application service providers, then we can say you don't have to work on the design, development, and implement or maintenance, because it's done with the cloud environment. Then some firms offer what we call the internet business services, which means powerful web-based support for transactions, such as order processing, billing, and customer relationship management. This is again quite common nowadays, that people actually working in different capacities. Then offshore outsourcing. Offshore outsourcing or global outsourcing means you are shifting IT development support operation to other countries. This is quite common trend nowadays. Countries like Sri Lanka, India taking over a lot of IT development coming from US and Europe in the similar fashion. Right. Then in-house software development, we can decide to choose developing your own software system or purchase and customize it. But most importantly, one thing you should think about is use the term total cost of ownership. What it means, let's say you develop a system and then you spend some money on it, and that's not the end. Each and every year you might find bugs, right, which you need to correct. So you have to think about all these, not the price of the software, but also like in case if you are managing, how much cost is involved, right? So the question is whether we are going to develop or whether we are going to purchase, right? So you have planning and analysis, or after that, you have to make this decision. If you are thinking of developing, then we call in-house environment, or else purchased item, then we can say commercial software package. And then you can have a customized in between. Right. So if you look at the reasons for in-house development, we need to satisfy unique business requirements, minimize the changes in the business procedures and policies, meet constraints of existing systems, meet constraints of existing technology, and then develop internal resources and capabilities and satisfy unique security requirements. If you want to purchase a software package, the concern could be the lower cost, and you require less time for the implementation. You might get a decent reliability and performance benchmarks, and then you need less technical development staff. Then future upgrade provided by the vendor, obtain user from other companies. Right. So last slide for today. So in the standard version of software product, it does not satisfy company requirements. The firm can consider adapting the package to put its need. So the idea is you might make some changes. So how do you do that? There are three ways you can talk about in customizing software package. So you can take the basic package and then we'll ask vendor to customize. Or you negotiate directly with the software vendor to make enhancement to meet needs by paying a charges. Or you can purchase the package and make your own modification. Okay, so that's all what I have for today's session. And we will discuss from the next week again about machine learning, giving introduction to how we can learn from data. So that part will start from next week onwards. Any questions? And if you don't have, we'll